Cancer is merciless. It starts quietly. One cell goes wrong, then another, until a doctor sits across from you and says the words. It doesn't care who you are, how old you are, or how much time you thought you had left. It's one of the most relentless things in nature. And here's the unsettling part. It's been with us from the very beginning. Most people assume cancer is a modern problem. We blame processed food, pollution, sitting at a desk all day. Those things matter, sure. But the real story goes back much, much further than any of that. In 2016, researchers digging in a South African cave found something that rewrote what we thought we knew. It was a small foot bone, a fragment most people would have walked right past. But it belonged to a human ancestor who lived roughly 1.7 million years ago, likely an early Homo species, or possibly an Australopithecine. Researchers are still debating exactly which. The bone showed unmistakable signs of osteosarcoma, an aggressive bone cancer. Not a healed fracture, not an old injury. An actual tumor, growing inside a creature that walked the earth long before our own species existed. The same research team found a benign spinal tumor in a separate skeleton from the same era. Finding two of these growths in fossils nearly 2 million years old tells us something important. Cancer isn't new. It's ancient. Here's why we don't find more evidence of it, though. Cancer mostly attacks soft tissue, organs, skin, blood, and soft tissue doesn't fossilize. It simply disappears over time. Bone is really the only thing that survives long enough for us to study. So whatever we're finding in the fossil record is just a sliver of how much cancer actually existed. Scientists call this a preservation bias. We only see the cancers that happen to leave a mark on something hard enough to last. That's part of why mummies have been so valuable to researchers. They preserve soft tissue in a way bone never could. Using CT scans and other imaging technology, scientists have found tumors hiding inside Egyptian mummies thousands of years old. One study scanned over 100 mummies and turned up several cases. A woman in her 50s with a breast tumor from 2,000 years ago, a man in the Sahara with prostate cancer, dated to over 2,000 years back, children with leukemia, pharaohs with bone tumors. Between the fossils and the mummies, a consistent picture emerges. Ancient people got cancer regularly. We also have it in writing. The Edwin Smith Papyrus from ancient Egypt dates back roughly 3,600 years. It describes bulging tumors in the chest, and the text is blunt about the outcome. There is no treatment. That's a doctor, nearly 4,000 years ago, admitting defeat in plain language. The name we still use today comes from ancient Greece. Hippocrates, writing around 400 BCE, called it karkinos, the Greek word for crab, because the swollen veins around a tumor reminded him of a crab's legs spreading outward. A Roman physician later translated that into Latin as cancer, which also means crab. That's the word that stuck. For thousands of years, across completely different civilizations, people observed this disease, wrote about it, tried to make sense of it. They just had no idea what was actually causing it. So what is cancer really? It starts when a single cell's DNA gets damaged or copied incorrectly, a mutation. Most of the time, the body catches these errors and fixes them. Your immune system acts like a tireless inspector, checking that every cell is doing its job properly. But occasionally, a mutated cell slips through, starts dividing uncontrollably, piles up into a mass, and pushes into the tissue around it. That's cancer. And here's the uncomfortable truth. Mutations happen naturally every time a cell divides. The more cells you have and the longer you live, the more chances there are for one of those mutations to slip past the system. That risk isn't unique to humans either. Tumors have been found in duck-billed dinosaur bones from 70 million years ago. Ancient fish had cancer. Even trees can develop it. Anything alive that grows and reproduces will, sooner or later, make a mistake somewhere in the process. So did ancient humans actually get cancer less often than we do today? Probably, but not for the reasons most people assume. The biggest factor is lifespan. Most ancient humans died young, from infection, injury, predators, or starvation. Average life expectancy hovered somewhere around 25 to 35 years. And cancer takes time. Most cases develop after age 50. If you died at 30 from an infected tooth or a lion attack, cancer simply never got the chance to show up. Ancient humans also faced a different set of risks. They didn't smoke tobacco or breathe industrial chemicals, and they ate whole, unprocessed food while staying physically active, all of which lowered certain risks. But they had their own dangers too. Smoke inhalation from cooking fires, chronic parasitic infections, unprotected sun exposure. It wasn't a cancer-free paradise. People just tended to die of something else first. So why does cancer feel so much more common today? Part of it is simply that we live longer. Modern medicine wiped out most of the things that used to kill people young. Vaccines, antibiotics, safer childbirth, basic sanitation. So now millions of people are living into their 60s, 70s, and 80s, which happens to be exactly the window where cancer tends to develop and get caught. The other part is detection. We now have the technology to spot a tumor the size of a fingernail using MRIs, CT scans, and blood tests. Ancient physicians could only see what was visible on the surface. Most internal cancers went completely unnoticed. People simply died, and no one ever knew why. And yes, modern lifestyle factors do raise certain risks. Tobacco is directly linked to lung, throat, and mouth cancers. Processed red meat is linked to colorectal cancer. Obesity is connected to more than a dozen cancer types. UV exposure causes skin cancer. But the idea that cancer is some modern invention, born out of industry and chemicals, simply isn't true. It's been riding along with life on this planet for a very long time. Understanding just how old cancer is actually helps scientists today. If it's been present for millions of years, that means it's woven into the basic mechanics of multicellular life itself. And that's led researchers to study something genuinely strange. Why do some animals seem almost immune to it? Elephants are the standout example. They have roughly 100 times more cells than a human and live about as long as we do. By simple math, they should get cancer far more often than we do. They don't. The reason comes down to a gene called TP53, a tumor suppressor. Most mammals carry one copy of it. Elephants carry around 20. When an elephant's cell detects DNA damage, instead of trying to repair itself the way our cells do, it simply self-destructs. Zero tolerance, and it works remarkably well. Scientists are now studying this exact mechanism to see whether it could inspire new cancer treatments for humans. The fossil record helps too, letting researchers track how cancer rates and patterns have shifted over enormous stretches of time. It isn't just a medical problem, it's an evolutionary puzzle, and understanding its deep history is part of solving it. A bone, 1.7 million years old. A tumor, growing inside a creature that lived before language, before fire, before anything we'd recognize as civilization. And cancer was already there. It's one of the oldest adversaries our lineage has ever faced. For nearly 2 million years, we could only watch it happen, naming it, describing it, comparing it to crabs, without any way to stop it. But for the first time in that long history, we actually have tools to fight back. Chemotherapy, immunotherapy, gene editing, targeted therapies, early detection, vaccines that prevent certain cancers before they ever start. We're living in the generation that's finally pushing back against an enemy that has followed our species for almost 2 million years. Cancer is older than us, older than our language, older than any idea we've ever had about what it means to be alive. But now, at last, we're learning to speak its language, the language of cells, of genes, of DNA. And for the first time in 1.7 million years, it's starting to lose ground.